Hello everyone. Today's topic is Thevenin's theorem. Before going into Thevenin's theorem, we have to get some knowledge about source transformation. Replacing one source by an equivalent source is known as source transformation. A practical voltage source can be transformed into an equivalent practical current source and vice versa. Here we are having a voltage source ES in series with a resistance RS. A load resistor RL is connected like this, and from this diagram we can write current through the load resistor R is equal to ES divided by RS plus RL. And this is a current source in series in parallel with the resistor RS. Load resistor RL, and from this diagram we can write current through the load resistor is equal to IS into RS divided by RS plus RL. And here the voltage source is transformed into an equivalent current source. For these two circuits should be equivalent for these two circuits to be equivalent, it should satisfy this relation. Here we are having a voltage source in series with a resistor R. It is converted into a current source, transformed into a current source in parallel with the resistor R. The resistor value will remain same. Then what about the magnitude of current I? This current source should have a magnitude such that I is equal to V divided by R. We are considering an example like this. 10 volt source in series with 2 ohm resistor is transformed into a current source in parallel with the resistor. Resistive value will not change. It will be 2 ohm itself. And magnitude of I will be equal to V by R. 10 by 2, we got it as 5. Then a current source in parallel with resistor is transformed into equivalent voltage source. Resistive value will not change and magnitude of voltage will be equal to I into R. Here we are having an example. A 2 ampere source in parallel with a 3 ohm resistor is converted into an equivalent circuit where R is equal to 3 ohm and magnitude of voltage is equal to I into R. 2 into 3, that is 6 volt. Now Thevenin's theorem. Thevenin theorem is an analytical method used to change a complex circuit into a simple equivalent circuit consisting of a single resistance in series with a voltage source. Here we are having a linear network containing several voltage sources, current sources and resistances having two terminals A and B, and a load resistor RL is connected between A and B. Can be transformed into an equivalent circuit like this. This circuit is known as Thevenin equivalent circuit. Thevenin equivalent circuit will have a simple voltage source in series with a resistor. Magnitude of this voltage source is known as Thevenin voltage VTH, and this resistance is known as Thevenin resistance represented by R suffix TH, R Thevenin, RTH. Then statement of Thevenin's theorem. Thevenin's theorem states that any two-terminal linear network having number of voltage and current sources and resistances can be replaced by a simple equivalent circuit consisting of a single voltage source in series with a resistance. Value of voltage source is equal to open circuit voltage across the two terminals of the network. These are the two terminals of the network. So, open circuit voltage across these two terminals should be found out. And that voltage will be the Thevenin voltage or VTH. Then coming to the case of resistance. Resistance is equal to equivalent resistance measured between the terminals, with all energy sources are replaced by their internal resistance. Let's consider an example. We are having a circuit like this. First step is to find out the Thevenin voltage VTH. In order to find out Thevenin voltage, remove the load resistor between A and B. Then redraw the circuit. Now voltage across A and B is the Thevenin voltage. From this diagram, it is clear that voltage across A and B is same as voltage across the resistor R2 because current through R3 is 0. So this voltage and this voltage will be same. That is equal to I into R2 where I is current. That will be equal to V divided by R1 plus R2. Next step is to find RTH. In order to find out RTH, remove load resistor and replace all the sources with equivalent circuit. So the diagram will come like this. Now we have to find out the effective resistance between terminals A and B, which will be the Thevenin resistance. Here R1 and R2 are in parallel, then in series with R3. So the effective resistance will be equal to R3 series with R1 parallel R2. So we will get the effective resistance like this. Then the third step is to draw the equivalent circuit, Thevenin's equivalent circuit. Thevenin's equivalent circuit will have VTH in series with RTH. Value of VTH is VR2 by R1 plus R2 and value of RTH for this circuit is R3 plus R1 R2 by R1 plus R2. Now from this diagram we can write the equation for current as IL is equal to VTH divided by RTH plus R. Now steps to be followed. First step is remove the load resistance RL. Then find the open circuit voltage VTH across terminals A and B. Third step is to find the Thevenin resistance RTH as seen from A and B. Fourth step is replace the network by a voltage source VTH in series with a resistance RTH. Fifth one is find out the current through RL using Ohm's law. The equation will be like this. IL is equal to VTH divided by RTH plus RL. Now let's consider a problem. Terminals A and B are here. So the load resistor 24 ohm is taken as the load resistance. First step is to find VTH. In order to find VTH, remove load resistor and redraw the circuit. Voltage between A and B will be the Thevenin voltage VTH. From this diagram, it is clear that VTH is same as voltage across this 12 ohm resistor. That will be equal to current through this 12 ohm resistor into 12. This current will be 10 divided by 2 plus 12. So 10 divided by 2 plus 12 into 12. That is equal to 8.57 volt. Next step is to find RTH. In order to find RTH, remove load resistor and replace the voltage source with a short circuit. So the circuit will come like this. Here 2 and 12 are in parallel. So the effective resistance between terminals A and B will be like this. 1.71 ohm. Next step is to draw the Thevenin equivalent circuit. VTH in series with RTH. VTH value is 8.57 and RTH value is 1.71 ohm. Between A and B, connect the load resistor RL of 24 ohms. Coming to the next problem. Determine the Thevenin's equivalent circuit across terminals AB for the given circuit. First step is to find VTH. So the circuit will be like this. Now apply KVL to this loop. Applying KVL to this loop. So the KVL equation will be 50 minus 10I minus 5I minus 25 is equal to 0. From this equation, we can find out the value for I is equal to 25 divided by 15 amperes. Now, the next step is to find voltage between A and B, which is the Thevenin voltage. From this diagram, we can write voltage between A and B will be equal to minus voltage drop across this 10 ohm resistor. Voltage between terminals A and B. This voltage we have to find out. This is the Thevenin voltage. And we know that voltage between this terminal and this terminal is 50. That minus this voltage drop will give you voltage between these two terminals. Hence, we can write the equation for VTH as 50 minus voltage across the 10 ohm resistor. It will be 50 minus I into 10. That is equal to 50 minus I is 25 by 15. So, we will get the value for VTH as 33.33 volt. Then find RTH. You have to find RTH, remove the voltage source and redraw the circuit. From this circuit, it is clear that 10 ohm and 5 ohm are in parallel. So, the effective resistance will be 3.33 ohm. Then draw the Thevenin equivalent circuit. Then we are moving to the third problem. In the given circuit, find the current through 10 ohm resistor utilizing Thevenin's theorem. The first step is to find VTH. Now to find VTH, remove the load resistor. Load resistor is the 10 ohm resistor. 10 ohm resistor is removed and the circuit will be like this. Our two terminals are A and B. Now find VTH. From this diagram, we can write V1. We have considered the node voltages and from this diagram it is clear that V1 is equal to V2. Now apply or write node equation to the first node. First and second, node equation to the first node. So it will be V1 minus 10 divided by 2 plus V1 minus 12 divided by 5 plus V1 minus 20 divided by 1 is equal to 0. From this equation, we can find out the value for V1. It will be equal to 13.29 volt. So we got VTH as 13.29 volt. VTH is V1 itself. VTH is V2 which is equal to V1. So it is 13.29 volt. The next step is to find Thevenin voltage. Thevenin resistance. Now to get Thevenin resistance, replace the sources. So the circuit will be like this. And looking from A and B. Looking from AB, 5 and 2 are in parallel. So this can be replaced by 1.43 ohm resistor and that in parallel with, that in series, parallel with the 1 ohm resistor. This one in parallel with the 1 ohm resistor. So the effective resistance will be 0.588. So we got values for VTH and RTH. Draw the equivalent circuit. From this equivalent circuit, we can write the expression for current as IL is equal to VTH divided by RTH plus RL. Apply the equation, we will get the value for I. In next problem, you work upon this problem, solve it and do it as homework. Thank you.